What are solid principles? What is the difference between solid principles and design patterns? First of all, what is a principle in journal? A principle is a general or basic truth that must be followed and must not be violated, right? Similarly, solid principles are a set of principles which must be followed to develop flexible, maintainable and scalable software system. They are not optional. They must be followed in every application, okay? Whereas design patterns are concrete and solve a particular kind of problems in softwares, okay? For example, singleton pattern solves one problem of preventing multiple objects creation in the class, right? But maybe that problem does not exist in your software, so you do not need to implement singleton pattern at all, right? Therefore, design patterns are optional to implement and required to solve a particular kind of problem. Another unrelated example is like honesty, integrity, truth, all are the must principles of life which a human must follow. But like career paths like finance, education, technology, all are good careers. But you can choose only one to make a good career, right? Similarly, a great software can be made by using just one or two design patterns. But violating any solid principle is not good at all for softwares. In a way, solid principles are more important than design patterns. Here are the five fixed solid principles, and here is the list of some important design patterns. Not all, but yes, some. The next difference is solid principles are not concrete; they are abstract. Meaning, for example, to achieve a single responsibility principle, there is no concrete or fixed solution. You can achieve it by using various ways in your application. Whereas design patterns are concrete and solve a particular kind of problem in a particular way, right? So, for example, to implement factory pattern, there is a specific and fixed way to do it. So now the differences are clear, right? What is single responsibility principle? This is the first principle. Single responsibility principle SRP states that a class should have only one responsibility or a class should have only one reason to change. Let's say you have a class called employee. This class has a method calculate salary that calculates the salary employee salary. Now the get department method to get the department of the employee, okay? And another method save that saves the employee to the database. Now to save, add or delete employee to the database is not the responsibility of the employee. So it is like an extra responsibility, right? Therefore this violates the SRP because this class has extra responsibilities and one class must have same kind of responsibilities. Now to apply the SRP, we can separate the responsibility into two separate classes like this. And here is the code. In this example, we have separated the responsibilities based on the core employee responsibilities and the extra responsibilities which needs direct database interaction will be there in the employee repository class, okay? If you are aware about repositories and the services classes, then they are the perfect example of single responsibility principle which you can give. Another good example is if you have one invoice class, suppose, then add invoice and delete invoice can be the part of it. But sending invoice mail and error logging are extra responsibilities. So create separate classes for them to follow SRP there. The advantage of SRP is when a class have only one responsibility, it becomes easier to change and test. So if a class has multiple responsibilities, changing one responsibility may impact others also and more testing efforts will be required then, right? So this is the advantage of SRP. Great, I think now you know SRP. What is open closed principle? This is the second principle of solid principles. Open closed principle OCP states that a software entities like classes modules should be open for extension but closed for modification. In other words, in order to add some functionality in a class, do not modify the class, okay, but extend it, okay. For example, suppose we have a bank account class which has the properties name, address and balance in your account. And here you added one method also, which is used to calculate interest based on your account type. Now if the account type is saving, then the interest is 3%, and therefore interest amount will be balance multiplied by 0.3. okay. Similarly, if the account interest will be multiplied by 0.5 in another case. But suppose tomorrow we get a new account type, and that is current account, and for that the interest is 7%, then how you will add this thing? So what you will do, you will add one more else if condition here in the middle, right? So basically, inserting one more else if will violate the open close principle, because you are modifying the class rather than extending it. Now the question is how to extend this and how to follow OCP. The first step is to follow OCP, you must follow SRP first, because SRP is the prerequisite of OCP. And to follow SRP, you should only put the account level methods and properties in the account class like this. Okay. Then by using the SRP, you should only put the account, So then by using interface, you should create one interface I account with declared method calculate interest, which accept account class object as a parameter. Okay. Then implement the interface for separate class saving account and other account like this. And because you implemented the interface, you must have to define the calculate interest method here inside it. Okay. And you can put the same logic of calculate interest here. See, we have implemented SRP and our structure can implement OCP easily now. Now if you want to add the new account type, then you do not need to have to modify any class, right? Like this, you can add one new class current account, and same way it can be implemented I account interface with 7% interest. See, OCP implemented so easily if you will first implement SRP properly. The benefit is simple testing is required to test individual classes. But if you will keep on adding and modifying one class again and again, keep on adding it, then even for the smallest modification, you have to test the whole class again, right? That might not be an issue for the small projects, but yes, in big projects, more testing needs a lot of efforts. Great, I think now you know one more solid principle, and that is OCP. What is Liskov substitution principle? For this principle, I will first explain the normal definition, and at the end I will share one very easy statement about LSP. Let's see the normal definition first and understand with the help of the code. The Liskov substitution principle LSP states that an object of a child class must be able to replace an object of the parent class without breaking the application. Remember, child class, subclass and derived class are same things, and parent class, superclass and base class are same things. Okay, now let's see the example code. First we will see how to follow the Liskov substitution principle, and then we will see how we can violate the LSP. Okay, suppose you have a parent class employee which have two virtual methods, calculate salary and calculate bonus, like this. For simplicity, I am not calculating here anything but just returning 1 lakh as salary and 10,000 as bonus. Okay, now we have one class permanent employee which is derived from the employee class. This class override the calculate salary method of the base class and set a new salary, and this class will automatically get the calculate bonus method from the base class, right? Because we are not overriding it here. And as the rule of the inheritance, base class methods will be automatically available for the derived classes. Simple, right? Now we have one more class, contractual employee class, which is again derived from the employee base class. Here we will again override the calculate salary method of the base class like this. But this contractual employee class does not supposed to have this calculate base bonus method of the base class, because bonus is not applicable for contractual employees. Okay, therefore here we have to override the calculate bonus method and throw the error like this. Why we are throwing the error here? Because if we do not override the calculate bonus method and write no code here, then by default the contractual employee will automatically get the calculate bonus method of the employee class, parent class, like the permanent employee class inherited it, right? And if anyone in future will create the object of the contractual employee class, then that object will be able to call the calculate bonus class then, right? Which we do not want, because as per the rule of the contractual employee class, that should not be able to call bonuses, right? So to stop that, we have to override this method here and we have to throw the error. Now if someone will create the object of this contractual employee class and call this calculate bonus method, then they will get this error, right? Now let's first follow the LSP and then we will violate the LSP. First, inside the main method, we will create the object of the base employee class like this, and we will also create the object of the derived classes also here. Now first, we will call the methods from the base class objects like this. See, no problem, and 1 lakh and 10,000 will be the output as salary and bonus, okay? Because that we got from the base class methods, right? Now listen carefully and read the definition again. The LSP states that an object of a child class must be able to replace the object of the parent class. Okay, so as per the definition, we will replace the parent class object employee with the permanent employee child class object P employee like this to call the exact same methods. And see, your application will not break. These methods will completely work fine, right? And the output will be like 2 lakhs and 10,000 this time. That means here we are following the LSP for the permanent employee class case, right? Because here object of a child class is able to replace the object of the parent class without breaking the application. Now we will see how to violate LSP, when we will violate LSP. Now we will replace the parent class object employee with the contractual employee child class object C employee to call again the same exact methods like this, okay? Here the first call of calculate salary will work fine, right? But the second call of calculate bonus will break the application and this exception will come. So here object of the child class is not able to replace the object of the parent class because the application breaks, and therefore for this particular example where employee is the base class and contractual employee is the child class, we are not following LSP. Now might be you will say the error is expected, right? Because yes, we are throwing the error inside the calculate bonus method of the contractual employee class here. Yes, this is expected. We were forced to throw the error here. That is because we have to do, because otherwise I already explained you like how contractual employee class will automatically inherit this bonus method, right? But we should never design our classes and methods in this way, in such a way where we have to throw the error like this, okay? This thing we should avoid. So when designing base classes and derived classes, then we should make sure that whatever methods we are keeping in the base classes, okay, those methods must be applicable for the derived classes also. Derived class can override the base methods and that is completely fine, but by default if those methods are not overridden, then all the methods of the base class must be applicable for the derived class. That should be the ideal design approach as per the LSP. Like in our example, all employee class methods are applicable for permanent employee classes, right? All methods, and therefore that they are following LSP. But for contractual employee class case, our design is not good as we are throwing errors here, and because calculate method, we all know the reason, and that's why we are violating the LSP here. All right. Now we can correct the design, like we should to correct this design and to follow LSP for contractual employee also, we should remove this calculate bonus from the employee base class and put it somewhere else, like some other class, some abstract class interface, some other design we can do, but we should not do like this. Finally, as I said in the beginning, the short statement for LSP, or the in other words, what we can how we can define the LSP is, all the base class methods must be applicable for the derived classes also. All the methods. Okay, I think this is the simpler definition. Great. Now I think you have a good understanding of the LSP, and even in your projects you now know how to implement LSP, right? What is interface segregation principle? Let's see the definition first. The interface segregation principle, ISP, stated that a class should not be forced to implement interfaces that it does not use. Okay, so let me explain with the example. Suppose you have an interface iVehicle which has two methods, drive and fly, declared only. Okay, now you are creating a class flying car which will implement the iVehicle interface method, something like this. Perfect. But suppose tomorrow your manager asks you to create a class for just a normal car, okay? And then you will write the code something like this. Here this iVehicle interface is creating the problem for you, because fly method is not applicable for car class, but still you have to implement it, right? You have to implement all the methods of the interface, right? So what was the definition? The interface segregation states that class should not be forced to implement interfaces that it does not use. And here we are forcing on car class to implement the iVehicle interface methods, this fly method, and it does not use this, right? So we are violating interface segregation principle here. Now what is the solution then? One solution is, it is better to have multiple smaller interfaces than larger interfaces. For that, we will divide that big interface into a small interface like this, iDrive and iFly like this, and then car can inherit iDrive interface and implement just the drive method without any problem. And what flying class can implement both iDrive and iFly interface and implement both drive and fly method like this. So basically multiple inheritance, you remember, it is can be done by interfaces, right? Now we are not forcing any interface method on any class, right? So this is interface segregation principle. Segregate your interfaces as small as possible as per the derived class needs. Okay. What is dependency inversion principle? The definition is, the dependency inversion principle, DIP, states that a high level class must not be depend upon a lower level class. Okay, so what is high level, what is lower level? Suppose we have a data access layer class that is responsible for adding a customer to the database. Okay, and however, instead of depending on an abstraction like an iLogger interface, it directly creates a file logger object and call its method log method to write a log message like this. Here data access layer is the high level class and file logger is the lower level class. And you can see data access layer class is tightly coupled with the file logger class and is depend on it, right? But as per the definition, high level class must not be dependent on the lower level class. Therefore, this implementation violates the dependency inversion principle. Okay, the disadvantage of this is, if tomorrow you want to replace this logging technique or behavior in your own application, for example, from file logging to database logging, you want to modify inside the data access layer. Here is the file logger log method. Okay, the method is same, but you have to use a new class. Now the question, so it will be a tight coupling and you have to replace, like here we have only one data access layer class, but there can be multiple classes like this, and if you want to replace, then you want to replace all over this file logger with this new database logger. Okay, now to resolve that, we have that dependency inversion principle. And if you already know dependency injection, then you remember how to inject the dependency class from the constructor, right? So dependency injection is a design pattern to implement dependency inversion principle. Okay, it's a one of the way to implement dependency inversion principle. Now to implement, first we have to create an ilogger interface that declare the log method, as well as a file logger class that implements the ilogger interface and provides in its own implementation of the log method here inside. Now in the data access layer, inject ilogger object as a constructor parameter and store it in a private field like this. Then when the customer method is called, it uses the ilogger object to log a message instead of creating this file logger object directly, right? Now high level, this data access layer is high level, right, is not dependent on low level file logger class. As we are, you can see we are not using anywhere file logger inside this data access layer here. The benefit is, again, tomorrow if you want to replace this file logger with the database logger, then you can easily do it. Just then add a new class database logger, inherit the class from the ilogger, implement the log method as per the new requirement, and remove this file logger class. And then automatically your ilogger which you injected in the data access layer constructor will start pointing to the database logger method. Okay, because file logger is gone, now ilogger is referring to database logger. Now no need to change any code inside this data access layer or inside any other class which is using the ilogger. Okay, because now you are not coding for the classes, you are coding for the interfaces. That's it. Great. Now I think you know dependency inversion principle, right? What is dry principle? This is not among the solid principle, but yes, this is very important and very simple to know. Okay, so the first point is dry stands for do not repeat yourself, meaning once you have written one code, try to not repeat it anywhere else. Try to put that code in some method and reuse it again and again. Then second, do not write the same functionality multiple times. This is just the same thing. Third point is instead write code once and then use it at multiple places using inheritance. Now the same thing, but you can use inheritance. For example, you have written one method for 10 classes. Now what you do, for those 10 classes, create a base class and put your method over there in the base class. Okay, then all the derived 10 classes will automatically get it. So getting my point, so you are not repeating that one method at 10 places then. So this is the dry principle, and this is also very important.